our first one. Do we have enough information to show that we can use the hypotenuse leg congruence theorem?
Yes.
Okay, what information do we have to know to show it?
The right angle thing.
So the right angle tells us that they're right triangles, which was a requirement for hypotenuse leg.
And the hypotenuse, the line thing.
The hypotenuse is congruent, and now we also have to know that a leg is congruent.
That's all.
So do we know a leg is congruent?
Oh, wait, no.
Is it shown in picture 1?
Yes.
So which legs are congruent? These two?
Yeah, the ones
Or
with
these
ticks.
two?
The one's touching the right.
So we don't have any symbols that tell us that. They look congruent, but there's nothing that tells us that.
Oh.
So we have to be able to show that they're congruent. So we would need not enough info. Need to show that a leg or legs are congruent. Okay. Okay, so that's our first one. We don't know the legs are congruent. We can't say it. Our second one, can we use the hypotenuse leg theorem? Reggie?
Yeah.
And how do you know that?
They both share the same leg, so it has to be congruent.
Exactly right. Based on this right here, reflexive property. And then we have the two hypotenuses are congruent, and we know that they're right triangles based on those right angles. So our next one, Emil and his team have erected a cell phone tower and supporting guy wires. Explain how he could use the hypotenuse leg congruence theorem to show that the guy wires are attached to the ground at equal distance from the base of the tower. So we want to figure out how we can show that this leg is congruent to this leg. So in this picture, do we know that they are right triangles? Yes, we know they're right triangles. So step 1, right triangle. You don't have to write this part. I'm just showing you. Check. Number 2, we have to know a leg is congruent. Do we know that there's a leg that's congruent?
No.
So if you look at the picture, we see right here that both triangles share a side. They share the side DB. So we know a leg is congruent because DB is congruent to DB. And we know that by the reflexive property. Okay, so we know this one. So what is our third thing we have to show? We have to show that that hypotenuse, right, is congruent. Hypotenuse. I'm bothered by the way I spelled that. Okay, something like that. You know what I'm getting at least. Okay. Do we know that the hypotenuse is congruent? We don't, right? So to use hypotenuse leg, we'd have to show that. And by showing that, we would then know that this length here, AB, is congruent to BC. So what we need to show is that our hypotenuses are congruent. So need to show that AD is congruent to DC. Okay, are we okay on this slide? Do you guys need another second? Any questions? You good? Okay. So our next one is a review of corresponding parts. So I'm going to draw 2 triangles, and we're going to label the corresponding parts. So I have A, B, C, we're going to call this D, E, F. I'm going to ask you to take a second and list all the corresponding parts. I'm going to draw them on here. And then I have to send a... You okay?
You can't get it.
Oh. Okay. I'll just pause it as is. Once I pause this, guys, it's going to clear it. So I apologize. I have to go write a response back over here. So corresponding angles. Angles that have one arc. Give me an arc. Give me 1 second. Say it again.
A is congruent to B.
D, correct. Both of them have 2 arcs. Angle B is congruent to 3. Oh, that's fine. Okay, and C, Bree, did you want to do this one? Is congruent to? F. Nice job, guys. Okay, corresponding sides. So ones with 1 tick mark are AB, which is congruent to DE. Sorry, do you need a second? Okay, and then we have BC, which is congruent to FE. And then we have AC, which is congruent to DF. Okay. So we've now listed all the corresponding parts and all the corresponding parts, the sides and the angles. So there is something new that we're learning today. And so this is kind of just builds off of this. It's going to be a symbol that you're going to abbreviate. I'm going to make it like a little bubble over here. So we use CPCTC. And that stands for corresponding parts of congruent triangles are congruent.
What's that word?
CPCTC. Corresponding parts of congruent triangles are congruent. So CPCTC. So this is a very important acronym or thing we're able to use. So once we know that 2 triangles are congruent, so either by any method we've used, hypotenuse, leg, angle, angle, side, angle, side, angle, side, angle, side, 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 side. I don't know if I did angle, angle, side. So as long as we've shown it by that, any other part that we're looking for in the triangle, as long as it's the corresponding part, we know that they're also congruent. So as long as we have shown that the triangles are congruent, then we can say any part that's corresponding in there is going to be congruent. So this is what allows us to do that. Yes, Bree?
What's after the triangle?
Oh, that's the word R. So when we are writing a proof, what is our first step? What is always our first step? T-chart, yep. On our left-hand side, we have statements. Right-hand side, we have reasons. So when we begin this, we start by saying what is given. So right now, what is given is the fact that AB and CD bisect each other. And we know that because it was given. But because we know what bisect means, we know something about the segments that are being bisected. They're congruent. So I can say that, let's start with DM is congruent to MC. And we know that by the definition of segment bisector. We also know, based on this picture, or well, not based on this picture, based on the fact that it's being bisected, that AM is congruent to MB. And it's the same reason, definition of segment bisector. So when something is being bisected, remember it divides it into 2 congruent parts. And so since we knew they were being bisected, we knew it formed 4 segments, and then where it's on the same original segment, the 2 smaller segments will be congruent. So right now we know this portion. It is already reflected in our picture. So looking at this, would you like a second? Okay, so right now we look at this picture and we see that this segment is congruent to this segment, and this segment is congruent to this segment. So to show these 2 triangles are congruent, we have the option of side, 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 or side, angle, side. So we can either show that AD is congruent to CB, or we show that angle AMD is congruent to angle CMB. Which one do we think would be easier to show? Or we have enough information, Randall? The second one. What do we know about these two angles? We know they're congruent because of what type of angles are they? I didn't hear if you said it already. Okay, what type of angles are they? They're vertical angles. Nice job, guys. So here we are able to say that number 4, angle AMD is congruent to angle CMB. And the reasoning is definition of vertical angles. Okay, I don't have enough space on my page. You might. I'm going to create another T-chart just to carry it over. Instead of trying to write small at the bottom there. Okay, so I'm on step 5. With step 4, I'm going to draw it in red. I showed this step. That's what we showed. So what can we say about these two triangles now? So now we know that we have a congruent side, a congruent angle, and a congruent side between the two triangles. What can we say about the two triangles? They are congruent. So we have corresponding parts that are congruent, and so therefore the two triangles are congruent. So triangle AMD is congruent to triangle BMC. And we know this by which one did we use?
Corresponding.
So, which congruent theorem? We had a side, we had an angle, and we had a side. Close, yeah. SAS. Side, angle, side. Where that angle is the one that is in between the other two. Okay, so now that we have that, our ultimate goal of this proof, is to show what? Yep, so angle A is congruent to angle B. So that's our last step. Now that we know we have two corresponding and congruent triangles, we know that angle A is congruent to angle B by corresponding parts of congruent triangles are congruent. Our first step was to sketch overlapping triangles as two separate triangles and then mark all the congruent parts. So I marked the congruent angles. Is there something else that's congruent that I did not mark?
No.
Yes. No.
I'm asking it, so it's a pretty good guess that there's something else that we know is congruent.
Yes.
What else is congruent in this picture? And Cozy?
Angles.
GK and JH.
GK and JH. We don't know it yet, or we're hoping to show that. We know something else on this picture. But thank you for trying. Jeremy?
GH and GH.
GH is congruent to GH, right? So you see here that one whole side of this triangle is the same for both triangles. We even labeled them with the same letters because they're the same side, right? So we know that GH is congruent to GH. Yes, sir.
Now what type of problem is this? He was asleep. He didn't even see the problem. My solution was better than this.
Okay, he's also
I drew. I looked at my paper.
it up though. Okay, so we have these two. If you were going to prove this with a congruence theorem, which congruence theorem do we use? What do you have? You're on the right track. We have two angles and a side, so it's either AAS or ASA.
Is it ASA?
So ASA implies that the side is in between the two triangles, or the two angles. Is the side between the two angles?
No.
No. Right? It's not the included side. The included side would be JH and GK. So it's the one off to the side. So we know we could use angle, angle, side. Angle, angle, side. So AAS. So we're able to use AAS. Okay. Is it okay if I clear the slide? Okay, thanks. Okay. That wasn't him? Okay. So our first step in these is to start with statements and reasons chart. Remember, our first step is to list our givens. So we know that angle FGH is congruent to angle JHG because it's given. We also know that angle FHG is congruent to angle JGH because it's given. Okay. I struggle seeing it this way. I'm going to make two separate triangles. If you're okay seeing it this way, you're fine. But I need to be able to see it. I highly recommend that you draw your two separate triangles. So we have FGH. We have JHG. Based on my original, we know these. We know that. Okay, looking at this picture, we now see that we have two angles. G is congruent to angle H, and angle H is congruent to angle G. Okay, so we have two angles in one triangle that are congruent to two angles in another triangle. So we can prove this by angle, angle, side, or angle, side, angle. So angle, angle, side would involve us proving that G, J, or HF are congruent, or that FG and JH are congruent. If we wanted to do angle, side, angle, we'd have to show that GH is congruent to GH. So which one of those is easier for us to show? Here. So what'd you say? Yep, GH is congruent to GH. So we see that GH is congruent to GH. And how do we know that? Exactly right. GH is congruent to GH by what she just told us, the reflexive property. Okay, I'm going to draw in my tick mark in red so you can see what we just showed. So step 3 allows me to see this portion right here. And what do we know now? We now have shown that an angle is congruent to an angle, a side is congruent to a side, an angle is congruent to an angle. What have we shown? So SAS would be side, angle, side. Is that what we showed? What did you say? AAS implies that the side is not included. And so here we have an included side. Which one is the included side? Say it one more time, Raya. It's going to be ASA, angle, side, angle, where the side's wedged in between. So angle, side, angle. So I can see my two triangles are congruent. So 4, I have triangle FGH is congruent to triangle JHG. And we know this because of ASA. But that's not what we're looking for. We're looking for the fact that segment FG is congruent to segment JH. So segment FG is congruent to JH. And I can say that with my 5th step, because now that we have corresponding congruent triangles, that means that all of the corresponding parts are congruent. That's at CPCTC. So we have FG is congruent to JH. And we know this by CPCTC. So our last example, again, we start our chart with statements and reasons. Statements and reasons. Statements and reasons. Okay. It will have elements of this on your final, yes. And we're going to have a test on Monday. So, first step is to list what's given. So what's given is that we have FK bisects angle JHJ, and angle GFJ. And this is because we know it's given. Okay, when something is being bisected, what happens? It's what? Cut into two. What is about the two? They have the same, they're congruent, right? Same amount. Okay, so when this is bisecting these two angles, we see that GFJ is being bisected. That means that GFH and HFJ have to be what?
Bisected.
Congruent. Because it's being bisected, right? So cut into those two parts. Sorry, you said it and I was listening to somebody over there. So we know that we have angle GFH, which is congruent to angle HFJ. We know something else about being bisected. So that angle is being bisected, but also angle GHJ is being bisected. So what happens to those two angles down here? What do we know about GHK and KHJ? We know that they are also congruent, right?
Yeah.
So GHK is congruent to angle KHJ. And we know this because it's the definition of an angle bisector. Okay. I'm going to change my color real quick to show you what we just did. So for number 2, we showed that this angle here is congruent to this angle, and that this angle here is congruent to this angle. Okay? But, is that what we were trying to show? No, we're not there yet, right? So we need to show something that how these triangles are congruent, and we have to use one of the things in our toolbox, our pack, whatever you want to call it. So, can we use hypotenuse leg?
No.
No, because we don't know the right triangles. We can't use that one. So we have side, angle, side, 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 angle, side, angle, 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 side that we are eligible to use. So knowing this here, how can we figure out this angle here?
Vertical angle.
So they're not vertical this time. What's something we learned along with vertical? How are these two angles related?
Alternate.
Not corresponding, but you're getting closer. Starts with an L. There. Linear pairs, right?
Hey.
So we know that, number 3, we know that angle GHF and angle I wrote really big, sorry, HK are linear pairs. Okay. Do you mind if well, never mind. And we know this by the definition of linear pairs. What does it mean to be a linear pair?
You got a partner. That's the same issue.
Okay, not exactly. So remember, linear pairs are two adjacent angles that lie on the same line where their non-adjacent side forms a straight line. Okay, so we know that one's a linear pair. What do we know then on the other side? So that's symmetry. What do we know about F, HJ, and angle JHK?
So we gotta do it number 5. I can't do it because I'm just really.
We also know that they're linear pairs, right? And again, that's by that definition of linear pairs. Okay. Number 5, are you ready? Yep. So, what do we know about linear pairs? They add up to be how much?
180.
180. So two things that add up to 180. What do we call those?
Complementary.
Complementary is 90. What's
Supplementary.
supplementary? So we know that angle GHF and angle GHK are supplementary. I'm going to write sup. And we know the same thing about the other pair. So we know that angle FHJ and angle JHK are sup. And how did we know this? I wrote down linear pair postulate. Okay. I have 4 more steps.
Oh no, Ms. Jenkins.
Okay, so our last steps here is that we get to use the fact that we know that these are supplementary for these two sets of angles, that we know that all supplementary angles are congruent. Supplementary angles of congruent angles are congruent. That's how I should have said that, so I apologize. So here we have statements. We have reasons. We have we're on number 5. So we know that angle GHF is congruent to angle JHF. And we know this because supplementary angles or supplements of, supplements of congruent angles are congruent. And since we know that they have congruent angles, both their supplements are congruent, so therefore they had to be. Because you're taking the same thing and subtracting it from 180 in both cases to get our supplementary angles. Okay, so number 6. Now that we know that, number 5 we learned here. 5, that's a little big, so let me switch the size. So for number 5, we showed that this angle here is congruent to this angle here. So our last step is to show these two triangles are congruent. And when we look at that, we see that, let's go back, sorry about that. We see that triangle GFK is congruent to triangle, I jumped a step, I apologize, I'm just ready to go. Okay, so we have one more step to show. We have to show that either another side that's inside or in between the two angles are congruent. The easiest one to show is that the one between the two angles are congruent. So we can say here that 6 FK is congruent to FK or KF by reflexive property. Okay, number 7, we have that triangle GFK is congruent to triangle JFK. And we know this because right now, as it stands, you see that you have an angle, an included side and an angle, so that's angle, side, angle. And then number 8, we're interested in what we're trying to prove, that angle G is congruent to angle J. And we know this for corresponding parts of congruent triangles are congruent. Okay, sorry about those little errors in there in the last couple steps. Let me know if you have any questions.